Are you an SRE? A developer? A quality engineer who wants to tackle the challenge of improving reliability in your DevOps? You can enable your DevOps for reliability with Chaos Native. Create your free account at Chaos Native Litmus Cloud.
Hello, and welcome to my talk, Incident Response, Incident Management, and Alerts, and where do they fit in cloud operations? Now, if you just read that, and you're thinking to yourself, aren't all of those the same thing? Then you've come to the right place, because they are not the same thing, and that's exactly the purpose of this talk. I'm very passionate about the idea that these are not the same thing. Before we begin, I want to use a little analogy. This analogy comes from the fact that I really want a Tesla, and some of my coworkers recently got Teslas, and I'm a little bit jealous. So maybe I want to more emphasize the power of the Tesla than this particular analogy. But really, it's applicable. So when I was growing up, one of my first cars it wasn't a Honda Accord, it was actually the Acura, but it's very similar. And with the 1998 Honda Accord, when something breaks, it's pretty clear and we have a good understanding of what to do when that happens. And the types of things that can break in the 1998 Honda there's a lot of things that can go wrong, but they're nothing compared to what we see in the Tesla. Why is that? Well, technology has changed. So in the Tesla, not only are we dealing with the same mechanical challenges or some of the same mechanical challenges you find in the Honda, we have a whole bunch of other technologies that are bundled in here. So yes, things can go wrong with your brakes and your tires and your motor, even though the nature of the motor is extremely different. The Tesla is also running a whole bunch more software that you never found in the Honda. And the complexity of that software is such that it also is running in a cloud native type way with containers and microservices, etc. So when something breaks in your Tesla, finding out exactly what went wrong, you can't just rely on an alert or a check engine light. You have to dig deeper. And to dig deeper, you need better tools for it. So that's what this talk is all about. The nature of applications has changed to be similar to the nature of cars. If you think of your 1998 Honda as your monolith and your 2020 Tesla as your microservices cloud native application. And as a result, how we approach fixing those problems also has to change. So my name is Chris Riley. I am a senior technology advocate at Splunk. What does that mean? It's basically, I was a developer. I really enjoyed software development, but it wasn't my forte. So I'm a bad coder turned advocate. I couldn't give up the life cycle and what it takes to build better applications faster. So now I talk about it. If you scan that QR code, you'll get access to other information about me. Please connect. I love to hear from people who have attended my sessions, both good and bad. If you have feedback on how to do better, please let me know. That's how I improve. But also just reach out to say hi. And there's a few fun little games I have on my social profile there. So back to what we were talking about. And that is that transformation is a given in the technology space. It is hard, even in a 3-6 month span, to keep current on all the things that are going on in the DevOps and the application development market. So as a result, we have to think about change as a constant. Now, we can't just expect to do what we did historically with modern applications. That also has to change. And ideally, the way we monitor and support our applications should be ahead of the transformation of the application itself. Most organizations we find are currently in this lift and shift and refactor stage of application development. With a lot of companies are in that cloud native world, and they're born cloud native, and they kind of have all the practices I'm talking about today kind of ironed down from day one, where they've actually embedded their monitoring as a feature of their application. But most people don't have that luxury. We're going from shifting our workloads to the cloud and then breaking them apart with the strangler pattern and making them more like a cloud native application. So because this is happening, we have to acknowledge the fact that as we transform, we can't just think about supporting our applications the same way. What used to be in monolithic application architectures, we could always go to that one server and we could look at the alerts on that server, pull up the alerts, kind of see what's going on. And generally, because these servers were set it and forget it, the things that went wrong were predictable, like the 1998 Honda. I don't know if you've experienced this, but back when I was maintaining servers and data centers, we always had like one server, the Billy Bob server, and that Billy Bob server, every 2 weeks we had to restart. And when we restarted it, everything was magically better again. Did you try turning it off and on? And we did, and it fixed the problem. We weren't really looking at what was happening at the application, and alerts actually were enough context to address the problem, because that infrastructure never changed. The number of things that could go wrong were fairly limited. Now we're talking about applications with distributed architectures, microservices-based architecture. So instead of one server, we have many, many services all doing very small, very specific things. And each service has a contract to the rest of the organization. But the service itself doesn't care, really. So all they care is they take in some sort of input and they output some sort of data. But anybody can consume that service. Well, because the web of these things is interconnected in unknown ways, it's not possible for me as an operator to go to the Billy Bob server, because there is no equivalent in the Billy Bob service. There is no one service that I can just always go to, look at the events for that service, restart the service, and be good. We are not able to conceptualize and hold in our minds the architecture of these applications and the entire nature of the application like we could in monolithic days. So we can't expect to go and find the problem. The problem has to find us. And it has to find us in a way that has good enough context that we can resolve the incident quickly. So that's where, when we start to look at the relationship between the services, we more have a visual kind of like this. And again, if we were to approach it with an alerting approach, we could probably go and find an alert that would give us some sort of detail, but it may be the wrong source. Because we can have an API gateway throw an alert and say things are broken, only to come to find out way too long down the road that it had nothing to do with the API gateway. It wasn't the API gateway that was causing the problem at all. It just had cascaded down, and the API gateway was the first to scream at us. So this becomes very complicated. And as you can see, alerts are not sufficient in this type of scenario. But also, because of the complexity of these modern applications, the life of those who are on call becomes more difficult. Nobody wants to be paged at night. Being on call sucks. You could be a developer who's on call. You could be an SRE, a cloud operations engineer. Everything we do, and we are very guilty about talking about features and functionalities of technology, but everything we do is in the service of making the on-call experience better. That's ultimately what we're trying to do here. So we can get all convoluted about monitoring and observability and all that stuff. Really, all we're trying to do is make that on-call experience better. What does better mean? Well, first of all, it means hopefully you're never woken up at night. That may still happen. Second means if you are on call and you are woken up, you're the right person. It actually gets to the person who should be resolving the problem. If you aren't the right person, hopefully you're giving enough data that you can resolve it yourself or know exactly who to go to resolve it. So logs simply are not enough. You cannot be on call, go from an alert to logs. Everything has to change. Well, because of that, we get this beautiful new term, and it's called observability. And if you're really cool, you abbreviate it O11Y, maybe even pronounce it OLLY. Like that's the upper echelon of the terminology club there. If you're a good curmudgeon like me and you hear these terms, first thing you do is say, no, we don't need another term. It's just monitoring. Yes, you're right. Observability is just monitoring. But the reason we use the term observability is the nature of monitoring has changed, which means the things that we need to do to support our applications better has also changed. And in the world of observability, alerts are not incidents, and incidents are not tickets. Now, if you remember at the very beginning, I said you're in the right place if you think that these are the same things, because they're not. They are fundamentally different, and they need to be different. Because whereas alerts potentially got us to a log that was good enough, we now have to live in this world of incidents. But incidents imply something that are completely different than ticketing and using a ticketing system. Well, let's go back to the car analogy and see how this comes together. So alerts are like your check engine light. Your car has told you something is wrong. A system inside of your vehicle has screamed, I am broken, or something is not correct here. Tell them something is wrong. That's all you generally get with an alert. You get a pointer to an issue. Now that's valuable. If you're driving down the road, check engine light comes on, you're probably going to be more hyper aware of your environment and maybe start to think about taking action. So you pull over to the side of the road. What's the next step? Well, the alert itself, unless you have smoke coming from your hood and you know you're overheating or there's something else obvious that you can address, you don't know enough to fix the problem. So you need help. Well, that's incident response. Incident response is your roadside assistance. It's who you call to come and support you in finding the problem and resolving it. Now, maybe they get there and they can jump your battery, they can replace your battery, they can give you coolant, whatever it is. Maybe they can fix the problem. That's ideal scenario. Or maybe with their expertise, they understand that this has escalated and they need to bring in help. How do they do that? They take you to the shop. So you go into the shop and they plug you into a computer and they get diagnostic codes. Or in the case of the Tesla, they get a whole flood of information coming out of the system. So incident response is that whole life cycle of mobilization. And you want it to happen as quickly as possible so you can resolve the incident. Well, where does that put incident management? Well, the foundation of incident management came from ITSM practices, and it's driven with a ticketing system. In the States, we have something called Carfax. Carfax is the equivalent of incident management. It is a history of all the things that has happened to your automobile. So once your car has been brought into the shop, a Carfax record will be created. An incident will be created. And it will be historical details of everything that has happened, what happened, and potentially you can use that information in the future. That is what incident management is and should be. Although many organizations will try to use incident management and ticketing as their incident response tool. And that's not the most effective way to do it. And the reason it's not the most effective way to do it is a lot happens in the life cycle of an incident. From the alert to the creation of an incident, which is not just an alert. As a matter of fact, an incident can be many alerts put together. To paging, escalation, getting to the right person at the right time, giving them all the context, and then finally moving that into maybe CloudOps or a ticketing system or whatever it is to keep that system of record. Now, if this view didn't look complex, this view looks even more complex. This is an entire architecture of the life cycle of an alert from some sort of system, a tool, to creating an incident and mobilizing a responder. And potentially taking action inside the incident itself. So what we get with an incident over alerts is less noise, hopefully, depending on the nature of your systems. I still am blown away by the fact of the number of systems I see where they're like, oh yeah, we get 1,000 alerts a day and yeah, we just kind of ignore that. Why don't you go fix them? That should be your first effort. But the idea of an incident is less noise because incidents are aggregation of alerts. There's rules and logic associated of when something actually becomes an incident, when it is significant enough to be an incident. Incidents also give us more context. So alert are triggering off of something very specific in an application or the infrastructure. So the amount of detail is very limited, where an incident can be based on a history of incidents, can be linked and correlated with Confluence articles, run books, etc., which gets us to the point where incidents can drive action. Because there is more context and detail as a part of the incident, then there can be greater action and greater execution as a part of that. Now, again, all we're really trying to do here is make the life of on-call suck less, which is great because it also makes the application run better. So in a typical incident lifecycle, we have the process of acknowledgement. You touch a whole bunch of tools, you might reach out to a whole bunch of people. Usually there's two methods of interacting with other people. The first method is what we call spray and pray, where you blast it out to the entire organization and you hope somebody picks it up. Very common in the knock type environment, and it used to work okay, but it was never super effective. What happened is there's a lot of back and forth between people. You're touching a lot of tools to find the information you need. And the amount of touch points was tremendous. So it usually lasted about 6 hours and 5 reroutes, etc. This is totally based on the nature of your application, but this is actually a consistent average we have seen with customers. Then once you get to the source of the data, you found the right person, or maybe you do what's called lazy mobilization, where you always find that one person who fixes everything, but you quickly are on the path of burning them out. And you start towards resolution. Resolution is not just, we need to restart the service. Resolution is, we restarted the service and now everything is green, because usually, and especially in a microservices world, the source of the problem will cascade into other services and cause issues down the road, and it takes time for those all to come online. So with true incident response, and that was driven by a ticketing system, we're trying to normalize and flatten that curve. We're trying to get acknowledgement to be as quick as possible. That's the mobilization, roadside assistant. We're trying to touch as few tools as possible. That's context, understanding, getting to the right person, and then having the tools like run books to resolve the incident as quickly as possible. So this is all how this comes together. Our observability practice, which is monitoring, is what gives the alerts and the context to our incident response practice, which is mobilization and action, to our incident management and ticketing process, which is our record and tracking of incidents over a long period of time. And another way to look at this is kind of this hierarchy of knowledge or insight or success, ultimately, which is the alerts. We get tons of alerts, and some of them are useful, some are not. But they can roll up into incidents where we have more meaning, and we can start to mobilize and do something with the alerts that is meaningful and get that in front of the right person. Then through troubleshooting, the incident links us directly to a dashboard. And once we are at that dashboard, we start to get insights of what's actually going on, where we may dive into a log. At that point, we may be going to a log. In a microservices environment, we may be looking at traces and spans for the details of what's gone wrong. Everything should be right there that we need to resolve the incident as quickly as possible. Once we have insight and we know what's going on, we take action. So we want to compress the time between all of these steps. And we also want to reduce the noise, which would be shrinking this way of all of these steps. So if you came here thinking that incident response alerts and incidents and tickets were all kind of one and the same, hopefully you now understand that they are not. And what I'm encouraging you to do is, if you have not established a practice of incident response versus just using your monitoring tools and staring at dashboards and hoping that, at some point in time, something interesting happens on your dashboards, or you're using a ticketing system and hoping that somebody is really fast at typing tickets and they put enough detail in there that somebody will grab it and resolve the incident. Building a true incident response strategy is necessary for the SRE practice. It's necessary for any sort of cloud operations because the nature of applications in the cloud have changed. They're distributed. You don't have the Billy Bob server that you can always go to resolve the problem in the same way that you always resolve it. You don't have the 1998 Honda. You are now driving the Tesla. Congratulations. Now you have to support it in a different way. So hopefully that was compelling. Please, again, reach out if it makes sense. And thank you so much for enjoying me. Hopefully you enjoyed it. Joining me at another virtual event. The content here is fantastic. I know there's a ton of information out there. So for you to take a little bit of your time and spend it with me means a lot. So I hope to see you at another event, and have a great day.